The event involved an individual attempting to retrieve an item from a metal box situated in a puddle of water. Upon stepping onto the box, a complete electrical circuit was established between the box and the ground, consequently allowing electrical current to flow through the individual's body, resulting in death. It is critical to understand the properties of electricity and how it interacts with water and conductive materials. The electricity seeks the path of least resistance to ground. In this scenario, the metal box, the water, and the person became part of that conductive path. The absence of proper grounding on the metal box created a dangerous situation. Grounding is a safety measure that provides a low resistance path for electrical current to flow in the event of a fault. This path helps to quickly trip a circuit breaker or fuse, cutting off the power and preventing electrical shock. When an electrical fault occurs in a properly grounded system, the current flows through the grounding conductor back to the source. This high current flow causes the circuit breaker or fuse to trip, interrupting the power supply to the faulty equipment. Without grounding, the fault current can flow through unintended paths, such as a person who comes into contact with the energized object. Water is a good conductor of electricity, especially when it contains impurities such as minerals or salts. Pure water is a relatively poor conductor, but the presence of ions greatly increases its conductivity. This is why it is extremely dangerous to be around water when there is a risk of electrical shock. In the situation described, the puddle of water provided a conductive path between the metal box and the ground. This completed the circuit when the individual stepped on the box, allowing the electrical current to flow through their body. The human body is also a conductor of electricity, though its resistance varies depending on factors such as skin dryness and contact area. When electrical current flows through the body, it can cause a range of effects, from a mild tingling sensation to severe burns, muscle contractions, and cardiac arrest. The severity of the effects depends on the amount of current, the duration of exposure, and the path the current takes through the body. Even a small amount of current can be fatal if it passes through the heart. Electrical safety is paramount in all environments, especially those where water and electricity may be present. It is essential to take precautions to prevent electrical shock and ensure that all electrical equipment is properly grounded. Firstly, never touch electrical equipment with wet hands or while standing in water. Secondly, regularly inspect electrical cords and equipment for damage. Replace any damaged cords or equipment immediately. Thirdly, use ground fault circuit interrupters or GFCIs in areas where water is present, such as bathrooms, kitchens, and outdoor locations. A GFCI is a device that monitors the current flowing in a circuit and quickly shuts off the power if it detects a leakage current to ground. This can help to prevent electrical shock. Fourthly, ensure that all electrical equipment is properly grounded. Grounding provides a low resistance path for fault current to flow, which helps to trip a circuit breaker or fuse and prevent electrical shock. Fifthly, be aware of the potential hazards of working with electricity near water. Take extra precautions to avoid contact with water and ensure that all electrical equipment is properly insulated and grounded. Sixthly, if you are not qualified to work with electricity, leave it to the professionals. Contact a licensed electrician to perform any electrical work. The grounding system is a critical safety component in electrical installations. It provides a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices such as circuit breakers and fuses to operate and clear the fault. There are several types of grounding systems used in electrical installations, including equipment grounding and system grounding. Equipment grounding connects the non-current carrying metal parts of electrical equipment to ground. This helps to prevent electrical shock by providing a low resistance path for fault current to flow back to the source. System grounding connects the neutral point of the electrical system to ground. This helps to stabilize the voltage and provide a reference point for the system. The National Electrical Code or NEC provides detailed requirements for grounding electrical systems. These requirements are designed to ensure that electrical systems are safe and reliable. Some key requirements include the size of grounding conductors, the methods for connecting grounding conductors, and the types of grounding electrodes that are permitted. The NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors for various circuit sizes. The size of the grounding conductor must be sufficient to safely carry the maximum fault current that could flow in the circuit. Grounding electrodes are used to connect the grounding system to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. The NEC requires that grounding electrodes have a resistance to ground of 25 ohms or less. If the resistance is higher than 25 ohms, an additional grounding electrode must be installed. Ground fault circuit interrupters, or GFCIs, are another important safety device that can help to prevent electrical shock. A GFCI monitors the current flowing in a circuit and quickly shuts off the power if it detects a leakage current to ground. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. When a GFCI detects a ground fault, it trips the circuit in a fraction of a second, which can prevent serious injury or death. It is important to test GFCIs regularly to ensure that they are functioning properly. This can be done by pressing the test button on the GFCI. If the GFCI does not trip when the test button is pressed, it should be replaced. Electrical safety training is essential for anyone who works with or around electricity. Training can help to identify electrical hazards and take precautions to prevent electrical shock. Training should cover topics such as grounding, GFCI protection, lockout/tagout procedures, and the proper use of personal protective equipment. Lockout/tagout procedures are used to prevent accidental energization of equipment during maintenance or repair. These procedures involve disconnecting the power supply to the equipment, then placing a lock and tag on the disconnect switch. This ensures that the equipment cannot be accidentally turned on while someone is working on it. Personal protective equipment, or PPE, is used to protect workers from electrical hazards. PPE includes items such as rubber gloves, insulated tools, and safety glasses. It is important to use the correct PPE for the task being performed and to inspect the PPE regularly for damage. The arc flash hazard is a serious electrical hazard that can occur when there is a short circuit in electrical equipment. An arc flash is a sudden release of electrical energy that can cause severe burns, blindness, and even death. Arc flash hazards can be reduced by using arc-resistant equipment, increasing the distance between workers and energized equipment, and wearing arc-rated PPE. The NEC provides guidance on arc flash hazard assessments and the selection of appropriate PPE. Electrical safety audits can help to identify potential electrical hazards and ensure that electrical safety procedures are being followed. Audits should be conducted regularly by qualified personnel. The results of the audit should be used to develop a corrective action plan to address any identified hazards. Electrical safety is a shared responsibility. Everyone who works with or around electricity should be aware of the potential hazards and take precautions to prevent electrical shock. By following safe work practices and using appropriate safety equipment, we can create a safer work environment for ourselves and others. Electricity is an essential part of modern life, but it can also be dangerous if not handled properly. By understanding the principles of electricity and following safe work practices, we can minimize the risk of electrical shock and create a safer environment for everyone. The key takeaways from this information are: firstly, electricity can be deadly even in small amounts. Secondly, water is a good conductor of electricity, so avoid contact with water when working with electricity. Thirdly, grounding is a critical safety measure that helps to prevent electrical shock. Fourthly, GFCIs can provide additional protection against electrical shock. Fifthly, electrical safety training is essential for anyone who works with or around electricity. Remember to always take precautions when working with electricity and to seek help from a qualified electrician if you are not comfortable performing the work yourself. Prioritize safety above all else.